Bismillahirrahmanirrahim. Assalamu alaikum bachcho. Welcome to the video number 15 of unit number 11. In this video we will discuss some more aspects of sound waves. Sound is produced by vibrations which through a medium travel to our eardrum. Then our eardrum vibrate with the same frequency as that of the sound source. The range for the audible frequency range which human beings can hear is 20 Hz to 20,000 Hz. It is that any sound of frequency less than 20 Hz cannot be heard by human beings, and all the sounds which are having a frequency more than 20,000 Hz are also not audible by the human ear. This range also depends upon the age of people. Young people and children can hear the frequencies up to 20,000 Hz, but with the passage of time when they become old, the maximum range that can be heard is 15,000 Hz. Also, this audible frequency range depends upon the nature of the human ear. Different people of same age can also have different frequency ranges. Sounds of frequencies more than 20,000 Hz which are inaudible to human ear are called ultrasound. They have multiple uses in everyday life. Frequency of ultrasound is more than 20,000 Hz. It means that ultrasound's first property is it is having very high frequency. As the frequency of the wave also determines its energy, so we can say that ultrasounds are very energetic sound. According to the wave equation, V is equal to F lambda. If the frequency of the wave is small, the wavelength will be big, and vice versa. As the frequency will be big, so wavelength will be small. As we have seen in the first property that the frequency of the ultrasound is more than 20,000 Hz, it means that the wavelength is very small. This small wavelength will enable the ultrasound to detect very small object. This is the ultrasound machine which is used in hospitals for the diagnosis and treatment purposes. This is a picture. This encircled portion is used to make the ultrasonic waves to enter the human body through a transmitter. These waves are then reflected differently from different organs, tissues or tumors, etc. These reflected waves are then amplified and they form an image of the internal organs of the body on the screen of the computer as shown. Second use is removal of blood clots. The ultrasounds are of very small wavelengths, so they can cut down these small blood clots in the human arteries. This is the thyroid gland picture, which is taken from the ultrasound machine, and it helps the doctor to diagnose the thyroid situation. Sound is used to locate the underwater depths, like depth of a sea, or is used for locating objects lying deep on the ocean floor. The technique is called sound navigation and ranging, as it is a very long word, so we use abbreviation of the given word, that is sonar. Now how we will do this? In this ship there will be a transmitter. That transmitter will send the ultrasound waves to the seabed. From the seabed they will get reflected, and again they will be collected by the receiver in the system of sonar. This time duration which is taken by the ultrasound to travel to the seabed and return back can be called as T. Speed of the ultrasound will be known. As we know speed and time, so we can calculate the distance. S is equal to Vt, and this will be the distance traveled by the ultrasounds. And if we want to calculate the underwater depth, that will be half of the calculated distance. D is equal to S by 2. Sonar can also be used to locate underwater objects. Here is a submarine is detected with the help of a sonar. This is a water turbine. Next I am showing you the engine of an aeroplane. This is also very complicated machinery. A small crack or small defect in this engine can cause danger to a lot of lives. This is a ship and its engine. It is also very multi-layered and complicated machinery. So if there is any crack, in order to detect that, ultrasound machines are used as shown in this picture. These machines are used to detect the cracks without opening or penetrating into the structure. If in this case one there is no defect, so the image of the ultrasonic crack detector will be as shown in the picture. The second case, when there is a defect in the machinery, the image will be different. The engineers can compare the two images and check out for the problem that is occurring in the machine with the help of this ultrasound detector. Ultrasounds are also used for the killing of germs and bacteria. We used to brush our teeth every day. Here is the difference between a normal toothbrush and a high-tech ultrasound toothbrush. Ultrasound toothbrush kills the bacteria very well. 11.7 numerical. A ship sends out ultrasound that returns from the seabed and is detected after 3.42 seconds. If the speed of the ultrasound through the seawater is 1531 meter per second, what is the distance of the seabed from the ship? The time given is 3.42 seconds. The speed of the sound wave is given to be 1531 meter per second. Required is the depth of the sea or the distance of the surface from the seabed. According to the formula, S is equal to Vt. The distance will be 5236.02 meters. You can verify it by calculating. And the depth of the ocean will be half of the distance traveled by the sound wave, and it will be 2618 meters. 11.8. The highest frequency sound human can hear is about 20,000 Hz. What is the wavelength of sound in air at the frequency at a temperature of 20 degrees Celsius? What is the wavelength of the lowest sounds we can hear of about 20 Hz? Assume the speed of sound in air at 20 degrees Celsius is 343 meter per second. F1 is 20,000 Hz, F2 is 20 Hz, and speed of the sound is given to be 343 meter per second. We are required to calculate the wavelengths for these two frequencies. Let us start the solution. For solution, wave equation will be used. V is equal to F1 lambda 1. Let us take this lambda 1 on this side, then it will become, when F1 will be taken to the other side, the formula will become lambda 1 is equal to V by F1. I have just changed the size. Now put the values and get the answer. The lambda 1 will be 0.01715 meter or 1.7 exponential 10 power minus 2 meters. On the other hand, we will be using V is equal to F2 lambda 2 as speed is same for both the frequencies, so it will be only V. Lambda 2 will be equal to V by F2. Now again put the values. The wavelength of this frequency will be 17.15 meters. From this numerical, that higher frequencies have smaller wavelength and smaller frequencies have higher wavelengths. 11.9 numerical. A sound wave has a frequency of 2 kHz and wavelength 35 cm. How long will it take to travel 1.5 kilometers? In this numerical, the frequency is given to be 2 kHz. Kilo is not a standard international unit, so we have to use the prefix for the kilo, that is 2 into 10 power 3 Hz. Next, wavelength is 35 centimeter. Again, centimeter is not standard international. Instead of centi, we will put the exponential 10 power minus 2. It will be 35 into 10 power minus 2 meters. Distance traveled by the wave is given to be 1.5 kilometers. Again, kilometer is not standard international. Instead of the kilo, we put the value of the prefix, that is 1.5 into 10 power 3 meters. All the three prefixes were present in your 9th class book. in the prefix table. Next thing is the required. We have to calculate the time used for the traveling. First step, we will calculate the speed. V is equal to f lambda. According to this formula, speed will come out to be 700 meter per second. Then we will apply the distance formula. S is equal to Vt. So according to this formula, put the value of S as 1.5 into 10 power 3 and velocity as 700. Take the 700 to the other side. It will be divided now. Then time will be 2.1 seconds.